Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we're taking a look at Anova, or analysis of variance. We will demonstrate this using JASP, and as we do, we'll come to appreciate its application when it comes to research or statistics. Now, if you watch this video right to the very end, you stand a chance of knowing at least two things. One, you would be able to know another term that is used to describe Anova or analysis of variance. And two, you will be able to get to know how different Anova is from independent sample t-test. Now, if you are ready, let's start. Well, Anova is used when one wants to compare the mean of 3 or more different groups. So if you have a data set that has categories more than 2, and you want to see how the mean varies between these categories, then the best form of analysis to use is what we call the Anova, or the analysis of variance. Now, in undertaking analysis of variance, there's a key assumption that one has to take cognizance of. But before we go there, we mentioned that there is a way of describing analysis of variance, and that is Omnibus Test. Now, this Omnibus Test produces F statistics, and this F statistics compares the explained variance of a given data set with the unexplained variance to see if the explained variance is greater than the unexplained variance. Now, back to the assumptions that are considered when undertaking the Anova. One is the fact that the independent variable should be categorical in nature, whilst the dependent variable should be continuous in nature. Another assumption is the fact that the groups or the categories of the independent variable should be independent of each other. Another fact is that, or another assumption is that the dependent variable should be approximately normally distributed. That is to say, they should pass test of normality. And finally, there should be homogeneity of variance between the groups. Otherwise, the p-value that will be calculated or that will result for the F statistics may not be totally reliable. Now, the assumption or the null hypothesis that is tested for when one is undertaking the Anova or the analysis of variance is that there is no significant difference between the means of all the groups that are being compared. Now, having established all these theoretical bases for the Anova or analysis of variance, we now want to select one of our tools, which is JASP, and see how we can demonstrate this. But viewers, did you know that very soon we'll try to explore other varied statistical tools like Stata, like SPSS, like GraphPad Prism, like Python, like R, in doing similar analysis? Well, we encourage you to keep watching this channel to see how we're able to use all these different tools to be able to achieve the same results. But for now, let's see how we can use the JASP platform. Great, so we are on the JASP platform, and as usual, we'll come here, open data library, go to Anova, and then we'll select a data set that will help us to be able to carry out this. And so we select, in this regard, we select, yes, eye color. That will help us to do that. So now, response to eye color, one way Anova. Now, the description is that this data set response to eye color provides post-advertisement attitude towards a brand expressed by 4 different groups. Each group saw the same advertisement except for the aspect that was manipulated, the eye color of the model. Now, the variables here are the group, the experimental conditions, the blue being model for the blue color, blue eye, the brown, the green, the dawn are all the model colors for the eye respectively. We also have the subject, which is the participant number, and then the score, which is the attitude score on a Ligate scale of 7. Now, notice this point. This sample JASP file demonstrates the use of one-way Anova. Specifically, we assess the adequacy of the null hypothesis that the attitudes are the same regardless of eye color of the model. Now, this is the reference book from which this has been taken. You may want to refer if you want. Now, let's have a visual inspection of the data. So as we mentioned, it has the group, the subject, and then the score value. Now, let's see the analysis by the Anova. Now, mind you, what Anova does is that it tells you the difference between all the categories. without telling you exactly where the difference exists. Now, when you look at the p-value here, it tells you that the p-value is significant. So what we can say, why can we say this is significant? Because it is less than our significant level of 5% with a p-value of 0.05. So this is less than that. And when you compare this value to it, quite big, but it's not too big. Now, when you look at this, the interpretation of this value says that the results suggest some difference between the group, although the overall effect is somewhat small. That is what I was saying. This value is somehow small, and so we should expect only minor differences between the groups. Now, the VS into brackets or hyphen NPR shows that the evidence for the alternative hypothesis that a group differ from each other is at best about 3 in favor compared to the null hypothesis, a ratio which shows that the evidence is not very strong. Just as I was mentioning, the F statistic here is not really large, so we cannot really say that the difference between the two groups or all the groups being compared here are significantly different. But we can't just say exactly where the difference is occurring. Here it tells us there is a difference, but that difference is not too big, but we can't tell exactly where the difference is. There is another test that is done to be able to tell exactly where the difference is, and that is what we call the Post-Hoc Test. Now, we will discuss that intensively in another set of video. We encourage you to keep watching Catalytics video, and if you are new to the channel, we encourage you to like the videos. We encourage you to subscribe to the channel so you can always benefit from any new video that we release. This is Catalytics, and until we meet again, it's bye-bye.